Okay, everybody, I hope all you are fine. I have read what you write, Mohammed. There's no problem. Our course takes about 90 minutes today. Not much topic. That's enough for today. Yes, let's first check out what we have done in the last session. We have studied efficiency and no-load test of synchronous machine, and then as a second part of the course I have solved an exam question at a mid-level difficulty. And then yesterday I had a Turkish class. I have introduced another new topic I will talk today, and then I have solved a more difficult question, and it is recorded here, somewhere here. This, please. Now you have right now at least 3 questions solved. One is easy, one is mid-level, one is a difficult question. And I will also solve some other questions, but here are some other solved questions in spring term last year. Here are video solutions, questions 1 to 9 and question 10. Here's a solved exam sheet, and then here's also final paper solved in video, question 1, question 4 and 5. Possibly at least one of them belongs to synchronous machine. I'm not sure. Yes, synchronous machine. But I will tell you when you examine on this question. We need to complete one more topic to understand this question better. Okay, there are some others I will find and show you. There are some other solved videos, but I haven't published them yet, so when I find them I will upload and you will watch if you want. Okay, here are at least 3 questions at your level to solve. Okay, let's start today's topic. Today again we talk about some characteristics, and then again I will try to solve another question for you. Okay, let's complete the first file. Okay, in the previous course we have examined some characteristics, which is no load curve, sometimes we say open circuit characteristic or open circuit test, all no load test. All of them means the same, have the same meaning. We know this. It looks like this because behind EMF there is flux, because flux current relation is saturable and it is controlled by field current. When you change field current, flux will change, and EMF as a function of field will change. So EMF is a function, another function of field current. Here you see how it changes. Now today, as a new topic, we talk about short circuit test first. It is easy, but there are some restrictions. I will talk. In these tests, first, we keep rotor speed at its synchronous value constant during the experiment. That the experiment is short circuit experiment or short circuit test, short circuit characteristic. Yes, it is a straight line. During this test, we will change field current and we will measure armature current of one phase. Here is a controllable dependent voltage source. By changing field current, there is a changing magnetic flux. That magnetic flux induces electromotive force in armature one phase winding, and that induced voltage will drop here. Ta-ta! In this case, armature coil winding is short-circuited. But take care. First, there is no field current in the beginning. There is no field current. Start here. And then apply short circuit to armature terminals and then carry out the experiment. How to carry out? Start increasing field current, measure I1 and IF, then plot the relation. That is the relation. As you see, it is a straight line. Because it is easy, you know. When you increase field current, there is an increasing flux. Flux result in some EMF increase. Since impedance of the winding is constant under unsaturated conditions. You know, there's a relation IF and flux. You increase IF here, you see, there's an increase in flux. If this is linear, that is linear. If that is saturated, so here will be saturation, but in fact it is somewhere here, because since the machine is short-circuited, here is approximately 10 times I1 nominal can be seen at the terminals. The current will be 10 times larger since it is short-circuited. So saturation would be somewhere here. Rated current, let's say I1 nominal, is somewhere here. So the saturation would be much more further. So we always see the linear part in short circuit curve, because there is no point in leaving these winding in a danger. I mean, if we conduct that experiment under 10 times of rated current, such a high current will be dangerous for the armature coils. So there is no need to create such a dangerous situation. We always operate systems in rated region, in nominal region. Rated means nominal. Türkçe'de anma da diyoruz. Anma. TR anma. Etiket değeri. Now, why we conduct such an experiment? We conduct such an experiment to measure impedance. Yes, that is the tangent. Here is the slope. Slope is constant. Slope is I1 over IF. Constant, as you see. Now, we combine those two results together, open circuit test and short circuit test, and find out the impedance. How can we manage this? First, let's say array is neglected. And then there is only one term in the impedance, which is excess. So EMF, here is excess, here is short circuit across one phase terminals. Here is alternating dependent voltage source EF, and then here is short circuit current of stator armature. So excess is equal to, impedance is equal to voltage over short circuit current. If you measure array, let's say array can also be measured by some other techniques. For example, you can use ohmmeter, you can use DC voltage, and you can measure array independently, and then when you know array, you can find, let's say, if you know array, so impedance is equal to EF over I1 short circuit can be calculated. Since you know array by DC ohmmeter measurements, and then ZS is equal to array plus excess squared all in square root. So excess can easily be calculated by this equation. Excess can be calculated. We conduct open circuit test, we conduct short circuit test, and then we define those parameters. Generally we neglect array, but we can also measure array easily by just using ohmmeter or some voltmeter ammeter methods. For example, here is the synchronous machine, synchronous generator, let's say. Here is the excitation coil, excitation coil, and then here are armature terminals. In armature between armature terminals, let's say UVW, the winding will be star connected or delta connected. Let's say it is star connected right now, and then here UVW and X, Y, Z. Here's the star point, neutral point, but we cannot reach right now. It is locked inside the machine. We just reach the external terminals which are UVW, and then we apply some DC here, let's say 12 volts for a short time of period, and then we measure voltage here by DC, let's say 12 volts, and then let's say here's ammeter, and then ammeter measures, let's say 100 amps. So you should conduct such an experiment as fast as possible, because the accumulator will be drawn, or winding will be heated, so calibration will change. Those kind of experiments must be conducted as fast as possible, must be conducted in a short time of period. So result, total resistance is equal to applied voltage DC here, let's say VDC, IDC over IDC. That is the total resistance. Here is one of the array, here is another, as you see, in those closed loop. So that is two array for star connection. Just draw the diagram and decide what it is, and then you can easily calculate array. It would be such a value, and then you know the impedance squared minus array squared, all in square root, is equal to XS, which is synchronous reactance. Okay, how can we manage this? In short circuit test, we know short circuit current. In open circuit test, we know EF. So let me write it down here. EF at a certain field current over I1 short circuit at the same field current must be divided to find out the impedance or excess. In this case, I have neglected array. So you choose a certain field current, and then let's say 5 amps here, and then read let's say 100 volts, and then come here 5 amps again, the same 5 amps, and then let's say 100 amps. So the EF at 5 amps, short circuit current at 5 amps, I mean here was 100 volts at 5 amps excitation, here were 300, was it? 100, just 100 amps again at 5 amps, so result is 1 ohm. That is the excess. You refer graphs and then choose the proper values and then got the ratio. That is the ratio. Ratio is the impedance. That was the short circuit test.